Okay, here's our graph of y equals 2 to the t, which we can make, and we should be able to make fairly accurately. It's a pretty smooth curve, pretty easy to follow the points. If you plot the points reasonably carefully, you can make good estimates. Okay? So this is really important now. This is something we should understand. So we want to find, first of all, f of negative 1.5. Okay? Well, this is f of t, so then I said x equals negative 1.5, we're using t. Okay. So f of negative 1.5, well, it's f of t. It means t, it better be negative 1.5 if we're going to use this graph to estimate this value, right? So we put t equals negative 1.5 there, and then we simply go up to the graph and go over here and find out what y is at that point. Okay? Do we understand this? Okay, there's a familiar picture. So here we have our value, y equals f of negative 1.5, right? And what do you estimate that value is? From my graph?
0.2.
0.2 or 0.3 probably, right? Okay, so let's just, okay, say that's approximately 0.2 because that's the first, did you say 2 or 3? Yeah. Okay. Now we want to find the value of y equals f of negative 1.5 plus 1, right? And of course that equals f of negative 0.5. How do we do that? Well, it's f of t, so that means we've got to find where t is negative 0.5, right?
Negative 0.5.
So here's t equals negative 0.5. So we come up to the graph. And at this point, y equals f of negative 0.5, right? Then we're going to write that as f of negative 1.5 plus 1, right? And that equals, of course, f of negative 0.5. And that's approximately, what's that look like?
6.
Yeah, but I'm going to correct you on that. I'm going to say 0.5. It's still not accurate. Okay? Just, yeah. If you do this very accurately, you're going to get a result that's kind of predictable. Anyhow, so this is the point. We can actually write the coordinates out, okay? The x-coordinate is negative 1.5 plus 1. The y-coordinate is f of negative 1.5 plus 1, okay? And that's approximately negative 0.5, 0.5 according to this graph. Now your calculator will tell you what these values are, right? Well, don't want to do that yet. We want to understand these graphs. We want to understand the behaviors of these functions. And here we have negative 1.5, f of negative 1.5. That's approximately negative 1.5, 0.2. Now, according to our estimates, the next thing we want is f of negative 1.5 plus 1 over f of negative 1.5, right? Okay? So how are we going to calculate that? Based on our estimates for f of negative 1.5 plus 1 is 5.5. And our estimate for f of negative 1.5 is 0.2. And that's 2.5. Okay? Now, would it be a big surprise?
Is it 2.5?
I'm sorry?
Yeah, never mind, just kidding.
Yeah. Now, you are not going to do this, please. You don't divide this 1.5 into this 1.5. Because these 1.5s are inside the f function, and you don't know what the f function is doing to them. There's no law that says you can take something that's an argument of this, of a function, and divide it into something that's an argument that, you know, has the same thing in the argument of the other function, okay? Only if this is a linear function would that be even remotely valid. Okay. Now, would it be a big surprise if this was really 0.6 and this was 0.2?
Nope.
So you might get 3, right? Would it be a big surprise if this was really 0.3 and this was really 0.5?
No.
No. So you could get like 1.67. So you get 1.67, you could get 3. You get 2.5, which is what we got. Or maybe this is 0.3 and this is, or maybe this is 0.25 and this is 0.5, and you get 2, right? From your estimate, these numbers are small. It's hard to estimate small changes, okay? Now, if you do the other two, you're going to get to start at one of them at 0.04 and then 1.4. So you're going to get a probably more accurate estimates if your y values are bigger. And you get a more accurate estimate of your ratio. Okay? Now, the reason we're doing that, well, just do it. Okay? And then we'll talk about why this is important and what this tells us about exponential functions, because there's something very, maybe the most important characteristic of an exponential function. Okay? First, do this exercise.